This is the back end of the day. I know some of you are probably tired, but hang in there. We're going to give, hopefully, an interesting talk. My name is Brian. I work for the Eclipse Foundation. Specifically, I work on our next generation of developer tools in the Cloud Development Tools Working Group. Sun here is my co-presenter. Sun works at Red Hat. He's an engineer working on some of our open source projects and integrating them into some of Red Hat's commercial products as well, and a valued community member at Eclipse. So I'm just going to run through some slides that's going to talk a little bit about what we do at the Eclipse Foundation. You know, we're well known for our Java IDE that's been around 20 years now. Who would believe it? It's 20 years old this year. But actually, we do a lot more at the Eclipse Foundation. So we have over 400 open source projects. And I'll talk a little bit about what areas they cover and highlight some of the projects as well. And then Sun is going to give a very cool demo using some of the technologies that I'll be talking about. We leave some time for questions at the end, but if you have a pressing question, feel free to jump in anytime and shout it out, no problem. And yeah, on your way out, we have some stickers over there, my business card, so you can grab it if you have any further questions about anything at Eclipse, don't hesitate to contact me. So yeah, I like this analogy, you know, comparing open source to bread. So bread has been around for hundreds and thousands of years, right? And imagine a world where bread makers didn't share their recipes. And you could only find a certain type of bread in one bakery in one corner of the world. We wouldn't have such a feast. You know, I know carbs are out of fashion these days, but everybody loves bread, and there's some nice tasty recipes out there. You know, it might seem trivial analogy, but that's what open source is about. It's about sharing, it's about taking it and adapting it and doing your own things with it. I know I'm preaching to the converted here, but yeah, nice analogy, bread. So every year we run a number of surveys at the foundation. Our IoT working group runs a survey. Our developer tools group runs a survey. And we find lots of interesting tidbits of information in there. Again, probably nothing surprising here, but the right two categories there add up to, you know, 74 of organizations responded that they were either thinking of or actually use open source in their solutions and their products. So, yeah. Adoption in the enterprise is strong, and it's only getting stronger. And you know, open source is out there, obviously. I would urge you to check out. It's easy to find our surveys. You might find some nuggets in there yourself that might help drive some of the decisions in your organization. Again, in this same IoT and Edge adopter survey, the vast majority of people wanted customization over anything else. So you might ask yourself, what's the difference between customization and control? So, you know, customization is about having a very broad feature set, and it's about customizing it to fit your needs. Interesting thing about open source, obviously, and the obvious thing is that, you know, if a software supplier exits the market, you're not like left with a dead source code, right? The source code could live on and you can continue to use it. Control typically is more, you know, in the proprietary end of the spectrum. You might have more control over the code, but you know, you have less customization, flexibility, and as I said, if the vendor goes bye-bye, well then so does your code. So a little bit more about who we are at the Eclipse Foundation. Very much community driven, so community first. I'll talk about numbers shortly. Code first as well, and very much commercial friendly. So our sweet spot at Eclipse is in the enterprise. Our software and our projects are used in a number of fields in education and nonprofit sector. Individuals take our code and do amazing things with it. But really, where we add extra value, I would say, is in the commercial space. And we do that through a number of different processes and structures that I will mention. Yeah, so by the numbers. As I said, over 400 projects. So, you know, if you thought of Eclipse as only being about the Eclipse IDE, we've got plenty more going on. We're a member-driven organization, so members pay fees to Eclipse, and we provide a number of services for those fees. And the reasons for becoming a member is really to collaborate with other vendors and with other companies on open source projects and driving the ecosystem forward. Almost, you know, getting close to 2,000 committers across the board on our projects. We've been around a while, 17 plus years, and yeah. These are, I would say, the 4 top-level areas that we focus on at the foundation. Cloud-native Java is really our heritage. You know, Java, our IDE is best known for Java. But newer projects include Jakarta EE, Adoptium, MicroProfile, and so on. And open source enterprise Java has really never been in better shape. I'd say it kind of, you know, it had a kind of a curve, and it dipped for a number of years, and there wasn't much innovation, and there wasn't much investment in enterprise Java. But in recent years, we've really seen increased adoption, and some new tools are really breathing new life into the cloud-native Java space. And it's worth noting that, you know, most of these development tools don't just support Java, they support all languages across the board. IoT and Edge, our IoT working group has been around 10 years now, so we're already building a strong legacy there. Automotive is newer. This is exciting, I think. As you all know, cars are essentially, or any vehicle is essentially a computer nowadays, so it needs a lot of software to power it. And tools, of course, which are also our heritage. So this is a reference architecture for an IoT and Edge stack. You know, you mightn't even be able to see it very well, but and I'm not going to talk about each thing here, just on a very, very high level. You have your constrained devices, you have your Edge applications and operating systems, and then you have your cloud applications. And this reference architecture was dreamed up, let's just say, by members of the working group, kind of as a thought exercise. Over there on the left, you'll see development tools, which is an area we cover as well. I'll talk about that more in a moment. So if we map our projects to that architecture, you'll see that we cover most of the boxes. The main point really here is that we have a very, very extensive toolkit for whatever you are trying to build for IoT and Edge, for desktop and cloud-based applications. I don't know, the real-time operating system box there on the left, on the bottom. We actually have that covered now with a brand new project, the Uniro project, which was announced a couple of weeks ago at EclipseCon. It's a very exciting, you know, real-time operating system project. So if you're interested more in that, I encourage you to visit the Huawei stand. They're one of the founding members of the Uniro project. So this is the area I'm more familiar with, working, you know, in cloud developer tools, and we also did kind of this thought exercise on trying to build a visualization of how our projects fit together. You know, we came up with the three categories there at the bottom. So we have Ide Technology. So these are platforms for building your developer tools, your integrated developer environment. So that's your code editor, your command line interface, your debugger, and all those pieces that fit together, right? And that's essentially what the Eclipse project is. It's a platform for building integrated development environments. There are function-specific tools that run in those environments. So, for example, Sprati and GLSP, that's Graphical Language Server Protocol. These are tools for modeling and diagramming in the cloud. So we're also seeing a lot of uptake of our tools, not represented here, in the embedded space as well. So for C++ development for devices, for example. And then on the other side, we have container development tools such as JCube. So, you know, it's not a perfect fit, and there is some overlap in this, but that's how we mapped it out. Now, OpenVSX at the top there is our version of, let's just say our version of Microsoft's VS Code extension marketplace. So, Eclipse and any application built on it can run VS Code extensions. And obviously VS Code is very popular. I'm sure if you're a developer here in the room, you probably use or have used VS Code. It's eating up the market. But the terms of Microsoft Marketplace say that only Microsoft products can consume their extensions. So we said, okay, we have Eclipse and there are a number of other projects, VS Codium, Gitpod, et cetera, that also support VS Code extensions. So we said we're gonna give these tools a marketplace that they could integrate and use. So we're really excited about that. We have 1,400 extensions listed, and it's growing every day. Okay. So yeah. On the edge, the cloud continuum, and on the development, on the left there you see in the development to operations continuum. This is kind of where we think our projects fit. These are just some of our projects. So we cover the spectrum there. With something for everyone, essentially. Eclipse IoT working group. Very, very diverse set of organizations. And one thing I would say about our working groups, you know, our working groups are where our members convene and collaborate, is that it's really a level playing field. So you can have a very small organization with 10 employees come in, or you can have a very, very large enterprise organization, and everybody contributes and works together on a level playing field. So very, very diverse set of members of our IoT working group. And we also have coverage in IoT in the hardware stack as well. So a sister organization of Eclipse is the Open Hardware Group. And this is kind of a representation of the main parts of the whole stack, right, from the processors and the cores all the way up to the IoT building blocks, development tools and tool chains for the processors and so on. So yeah, there's some overlap there. You'll see on the left, the Open Hardware Group covers some of that stack, and Eclipse projects cover other, and there is some overlap. So some great work really being done there in the Open Hardware Group. If you're working in that space, I'd encourage you to check them out. So the Open Hardware Group, RISC-V cores can be downloaded and installed. And there's a comprehensive toolkit from microcontroller to development tools to IoT tools. This is just a very, very high-level representation here. And I won't go into detail on that. Edge Native working group is a separate working group, a smaller working group, and these are the current members. Yeah. And One of the projects, the Eclipse Edge Working Group, is IOFOG. And this is essentially a centralized controller focusing on container orchestration. And I compare that with the FogOS project, which is more of a decentralized take on edge computing. It supports binaries, VMs, and containers. And listed there is some of the features. Yeah, so whether you're looking for a decentralized or a centralized solution there, in your edge applications, we have you covered. And finally, in edge, just want to call out the Zeno project. It's a next generation publish and subscribe protocol built from the ground up for edge. You can also run distributed queries with it as well. So transitioning into cloud developer tools, I talked a little bit about this already. These are some of the members. Interestingly, some of our newer members, Renesas, SG Microelectronics, and ARM, are all working in the embedded space, and they're really moving forward on bringing applications into the cloud and bringing developer tools into the cloud. It's worth mentioning that the cloud development tools we're building now, the next generation tools, are not necessarily there to replace the Eclipse IDE, right? I get the question asked all the time is, will the Eclipse IDE go away? The answer to that is probably, but probably not for another 20 years, a paradigm shift like that takes a long time, and there's companies that are heavily invested in tools built on top of the Eclipse IDE, and they're just not going to drop that investment overnight. It's going to be a kind of a very slow transition. So there are many companies who have their feet in the Eclipse IDE world and in the new cloud development tool world. We know everything is moving to the cloud, or most things are right now, so it kind of makes sense that developer tools are as well. And what are the advantages of having developer tools in the cloud? So I think the main advantage is just easier collaboration and easier setup for developers. I would say personally, being a developer and having spent days sometimes setting up my development environment in the new cloud world, you can just send your developer teams a link and they can load their development environment. They all have the same configuration, their standard workspace configurations, and you can just get started coding straight away. You don't have to worry about setting up your developer environment. So that for me is the main advantage of cloud development tools. There's plenty of other advantages as well, of course. So I mentioned earlier that Sun here works on the Eclipse Che project. It's the industry's first Kubernetes native IDE that runs in containers. It's architected for Kubernetes, but theoretically you can swap in any container model. Docker, for example, it's been architected in a way that you can plug in other architectures as well. So you have, it's kind of I like to describe Che as kind of a kitchen sink kind of solution for developer tools. It has everything. It has your editor, your IDE, it has plugins, and workspace management for your containers and so on. So that's Eclipse Che. These are just some of the adopting and contributing organizations, so it's got great traction so far. Theia is kind of a subsection. It's integrated into Che, but it's more focused on the IDE part. And there's a number of organizations as well contributing to and building on Eclipse Theia. So that was just very, very, bird's eye view of some of the focus areas at Eclipse and some of our projects. I don't know what you all are working on, but I encourage you to go to eclipse.org, explore our projects, explore our working groups, and get in touch if you have any questions. I'm going to hand it off to Sun now, who's going to just show off some things. Take it away.
Okay, so time for the fun. So this is going to be a demo that you can reproduce yourself on if you have a laptop with a browser. So what you would just have to do is click here. So wait a second, I have to switch the display. So okay. So yes. So just need to click here, and this is an instance of Eclipse that we are hosted at Red Hat. This is free of charge, limited in resources, but you can give a try. There's 30 days trials, and then you can renew it if you like. So every 30 days it would be reset from scratch. So if you click in this link, I will show you the details after, but it will start a very brand new workspace, and in few minutes you will be able to code and replay the demo I'm going to show you. But before showing the demo, so I've clicked there, so it's loading. What are we going to do? So the goal is to write, is to be able to write a program into that card. I don't know if is there anyone know what is this card? So it's microbit. It's a it's a microcomputer. It costs only 25 euros. As you see, it's smaller than a credit card. There is some LEDs and buttons, so you can interact, but you can also plug some sensors and other stuff. So I don't know if I can maybe show. So this is what I bought last week. So there's a lot of sensors there for to get the temperature or anything else. We can have a look after the talk if you like. And there is also a huge community around these cards. And the idea of what we're going to do is to use Eclipse to write a program that will write in the Rust language and be able to then to flash in there. So imagine that you have a laptop, you don't have anything installed on your computer. You would just have to click on this link, and then it will show up a browser. So you have to create an account first, but then once you click on it, it will jump into there. So this is Eclipse or Code Body Workspaces. So Code Body Workspaces is the Red Hat product that is built on top of Eclipse, but it is fairly the same things. So when I click there, it's Eclipse had a look to this GitHub project, gets some configuration information from a file that is located there. So maybe I can try to copy the link and show you just the project. Oh, I can show you in Che, okay, but let's do like that. Just show that. So this is the GitHub project that we're using. And there is a file here called the dev file, where we describe everything that is needed for Che to generate a new workspace, ready-to-use workspace. So you can code this project and to be able to flash it in this card. I'm going to plug it there, so it's tight. Okay. And we're going to use sorry. We're going to use the Rust language. Why Rust? Because it is quite easier to code with Rust with its type system compared to C++, and it is also as fast as a C++ program, even faster. There is when you code in Rust, there is no such difference when you're coding for embedded or not embedded. So it's very easy to get involved in there. There is also a huge ecosystem of open source libraries that are available in both worlds, so embedded and non-embedded. So when we started this, when I click on this, it generated this workspace. Okay, so this is your workspace, your own workspace. If I click on the bottom here, you can see that I've started several workspaces. I can close them, remove them, recreate them. For instance, here I've clicked several times on this link, and it generated me several workspaces. So these are actually clones workspaces with their own file system, and I can start to code right away on it. So if we look at the right, there's a space where we can see some containers and some commands that we have set up in the dev file. So, for instance, there's a check, which is kind of compiling the project, and then there is a command to build the firmware, a command to build the emulator and to run it. I'm going to do check. So, by the way, I'm not a Rust expert, but this is very fine because I have everything I need. I know how to compile it. It's as easy as clicking there on check, and I know how to run the emulator, for instance. So it would be as easy as clicking on this link, and I can also open the files and code. So it is a complete IDE. We have a Rust plugin. So the Rust plugin is actually a VS Code extension. Che supports VS Code extensions by default. So we can get all the extension from the marketplace. And what was so here? I'm not a Rust expert, but if I hit Control Space, I have some code completion information. Let's wait for for it to compile. It takes a while the first time, but so I'm just going to check if the device is running or not. Sorry. Okay, so it's connected. And then what we'll be able to do is to run the build of the emulator. We can then be able to test it. You notice that I'm using the Wi-Fi for from the conference, but it is not a problem because it is even faster. So when it is downloading things, it is actually downloading from the data center. So it's even if I have a very poor connection, it will work as good as I was in having that in a local connection, local laptop with a nice connection. And sometimes it is even so. Check is finished. I will run the emulator. the build of the emulator. So it is going to start, because when we're coding, we don't want to flash every time the code into the program into the card. So it is nice to have the emulator to build what we have done and to run and to test if it works or not. And let me check where I'm going to do my changes after in the next one. It's going to be there. So the idea is to change. So at the moment, so this is the code that it is going to do. To code, it is there's some button here, and I can press on it, and it will change the LED color. So it will go first there, and then in the upper left, and then bottom down. Okay, and what we're going to do is like display the two LEDs at the same time, and then display anything each time we click on the button. So we will just have to remove that, I guess. You see, so emulator build is done. I can see if it works. Emulator run. So there is, so it is running the emulation of the card, and I can open it in preview. So I can open it, and this is when. So this button is when we click on the button, and as you see, it is switching from one to the other each time I click on it. Let's try. So let's cancel it. Let's close it, and let's try to change it. Yeah, up. I think that's what I have to do. So I just need to do to run the same commands. Should be faster because it's only slow the first time. So emulator build, and then run. So you see it's quite fast. You can run it again in the tab. And it's not working, or maybe I have to refresh it. Ah, yeah. So see, each time I click, it will switch on both of the LEDs, or switch off the LEDs. So now, now that we have what we wanted to do, time to flash it in the card. It's the time to flash it in the card. So I have to run. Sorry. Have to run this command, firmware build. So again, this is something that you can try by yourself if you click on the link I've shown to you. So workspaces.openshift.com, and then you add a hashtag, and then the URL of the project. You can take a picture if you like. Yes. So by default, you don't have any. So the question was if we could do it for any project in GitHub. So we can do it for any project. By default, it would load a standard workspace. But if you have a dev file in the project, it will take it and load it. So so the advantages is that in this dev file, you have all the containers that contains all the dependencies that you need to build your application and to run the emulator and everything. So you see here, and this is something that you can share, like I'm sharing it with you just with that link. Yeah. So let's see if it has finished. Okay, it has finished, and normally it has. It has created there a file called eclipsecon-demo. So I'm going to remove the previous one. Yeah, let's remove everything. and download it again. So it's been downloaded. So as you can see, this is the one that we have downloaded. And I can use a command. So this is written in a README. So this one to flash it in my card. So I think it is this one. Enter. So it is flashing, and now let's see if it works or not. Ah, wrong button. Okay, so you see nothing, and then the two LEDs on. So it works. Great. And now it is time to upload. Okay, so but this is good. So again, you can try it yourself. You can buy this in Amazon. So what's next? What if you want to go further? So the good thing with that is that you can, it has a Bluetooth connection, but you cannot connect to the internet with that. There's no Wi-Fi connectivity. So what if we want to have, if we had some sensors like the one that I bought, and I want to collect the data and send it to the cloud, what could I do? So this is the idea of this slide. So this is basically what you can do next, or what I should do next for the next demo I will give next year here. So it's to use, for instance, Eclipse Foundation that I can install in a Raspberry Pi. And this project can be used as a gateway to get all the messages that are sent from this card using the MQTT protocol, and send it to that Eclipse Foundation that is stored there. That would be used as a gateway, and it would transform all the messages into a WebSocket or Eclipse Zeno or Kafka or any message broker, and send it to any application in a cloud. So once you are in the cloud, so for instance Kubernetes, if you have any Java application and you want to turn that Java application and to deploy this to Kubernetes, there's a project called Eclipse. I'm contributing to it as well. And this project the goal is to, with no configuration, you can, by just adding a plugin, a Maven plugin, create the containers and push that to Kubernetes. So that would generate all the configuration and push that to Kubernetes. And then, as you've seen, the last thing we can do is to, as you've seen in the demo, I had to download the firmware and then to use my computer to flash it. But this could be avoided. We can skip this step by using web USB. So the web USB is a protocol to expose your local USB ports to the browser. And if we do that, we should be able to directly from che having a command to directly flash the card. So that's my plan for next Sunday, next weekend. Okay, that's put it for the demo. If you have any question, feel free to ask now. It's time for questions. I think we have 6 minutes. No question? Don't be shy. Or you can do it in French if you like. No, still not. Okay, so thank you very much. Thank you, Brian. And yes, if you have more questions and you're really shy, we are in the Eclipse Foundation booth. So yes, feel free to come. Thank you.
Thank you very much. Don't forget you can grab some stickers on the way out, and my business card is there as well if you want to get in touch afterwards. Any questions? Thank you.